Okay, okay. So till this point we have discussed. We first Let me explain once again what we have done till this point. In the Liang Barksky line clipping algorithm, we find first the parametric equation of line. There is no need to write this form. How we can find the parametric equation line? Just you remember the parametric equation of line. Okay. I'm just for explaining you. I've just write all about this. Okay. So these are the parametric equation of line. In this parametric equation of line, the value of t is always between 0 and 1. 0 at the initial point, and at the end point your value of t is 1. Okay, so all the intermediate point in between 0 to 1, the value of t between 0 and 1. Okay, so these are the condition. uh, if your point is inside your clip window, these are the four inequalities condition. First check for the left boundary, then right boundary, then bottom boundary, then top boundaries. Okay, I have not done anything new. I just put the value of this equation in into this four inequalities condition. Okay, these are the four inequalities condition. Just put the value. Okay, and I just changed these four inequalities condition into a common form. These are the common form: t into pk less than equals to qk, where k is the represent the it is left side, or left, it is showing the left boundary, right boundary, top boundary, or bottom boundary. So corresponding value of k is equals to 1 2 3 4. Okay, so in this here we just get this common form, and after this common form we just write the value of p1 p2 p3 p4 q1 q2 q3 q4. We have not done anything new. We just substituting the value into one equation to another equation and finding this value of p1 p2 p3 p4 for left, right, bottom, and top boundaries. Okay, now there's some condition. First first condition: if your value of pk, this value of pk equals to 0, this value of pk equals to 0. What is the value of pk? As you can see, always pk is showing the delta x or delta y, means the y2 minus y1, x2 minus x1. Okay, if this value is 0, means your line, 1 minute, when this value equals to 0, means your line, the line which is given, the line is parallel to clip boundary. If the value of pk is 0, means the line is parallel to clip boundary. For if your p1 value is 0, means your line is parallel to left boundary. If p2 value is 0, means your boundary is parallel to right boundary. If it is p3 is 0, means it is parallel to right boundary. If uh, p4 is 0, means it is parallel to right boundary. So this pk value is 0, means it is a parallel to any of the boundaries. Okay, if this pk value is less than 0, means negative value, then the given line goes from outside to inside into your inside into your boundary or clip window. Means it is entering into your clip boundary or clip window. It is entering into clip boundary, is coming from outside and entering into your clip boundary. If the value of pk is greater than 0, means some positive number, means your clip window is the line, sorry, the line is goes from inside to outside. Inside to outside means it is exiting your clip window. This condition, positive condition, shows the value of positive condition where p is showing your line is moving from inside to outside, means exiting your clip window. And if the value is negative, means your line is entering into your clip window. Let's miss this example where it's clip window. This clip window means if the value of pk is 0, means it is parallel to any of the clip boundary. Okay, this is the parallel lines. Okay, if the value of is negative, means negative means is entering into your clip boundary from any direction, it is entering. Okay, if the value is positive, means it is from inside, it is moving outside. Okay, these these the value of pk is showing, or using the value of pk you can determine the position of line, where it is parallel, or it is entering, or it is exiting. Okay, now if this condition is clear, if this condition is clear, means your pk value is 0. Just suppose your pk value, p1 is 0, and q of p1 is 0, you have determined, and q value of q is less than when it is completely outside. 1 minute, once again let me draw one more clip. Okay, I'm just want to say your pk, you have determined pk is 0, means it's parallel. If it is parallel and qk value is negative, after pk your qk value is negative, means it is completely outside. It may be here, it may be here, it may be here, it may be here. It is not passing from your clip window, so you can completely reject. Okay, and if pk is 0 and qk is greater than 0, if pk is 0 and qk is greater than 0, means some positive number, then it is showing the line is passing parallel to window. It is a clear if pk is 0 and it is passing from your clip window in any of this position your line may have. Okay, if it is qk is zero, negative, means it is completely outside. Qk value is greater, means it's passing from your clip window. If the value of qk is 0, now it is 0, pk is 0 also, qk is 0 also, means your line is passing from the boundary. It is not entering or not exiting, it is passing from the boundary or on the boundary. This may position or any boundaries equation it is showing. Is it clear? Now is it clear to all of you? Okay, so the second condition, first condition is clear, pk, if pk is 0, now pk is less than 0, means you are entering into your clip window, means there need to be some kind of clipping because you are entering into your clip window. In the same way, your qk is greater than 0, means some positive number, means you are exiting from your clip window. So there again you need to be clipping, means you have to find the intersect point, at which point you are intersecting to your clip window. So how we can find these points? Okay, so again I'm writing some points. The first point has been clear. The second point is pk is less than 0. The second condition, if you are entering into your clip window. So the value of t you will find the maximum of 0 or qk by pk. What which the value is greater you will pick. And if your pk value is greater than 0 means you are exiting from your clip window, then the value of t you will pick minimum of 1 or qk by pk. So this is your condition. Now the whole clipping algorithms I'm explaining once again. Steps. Steps. Let's see. So, okay. Just consider this is your clip window. The first condition for pk is clear. If the value of pk is okay, somebody is waiting in the room. Waiting. Okay, so this is your clip window, and the first condition has been clear. If it pk value is 0 means it's parallel, and if the value of pk is less than 0 means you are entering, and pk is greater than 0 means you are exiting. Okay, and what is this? What I'm talking about here is the value of t. Okay, so it is showing. Check the condition if you are entering. The first case pk is less than 0 means you are entering into your clip window. Suppose this is the line we are talking about. Okay, this is your x1 y1 and this is your x2 y2. At the value of t at this point is 0, at the value of this point t is 1, and this is the intersect point we need to find. And what the time you are reached at this intersect point, we just consider it's at t1. So the value of t1 is maximum of 0 or qk by pk. Okay, means the value of t is changing. It is from 0 we have reached to t1. Means t is changing. Okay, if you are exiting from your clip window means your initial again next you are exiting from your clip window. Suppose this is the case. So this is your initial point x1 y1 and this is your end point x2 y2. Okay, at this point you are exiting means it's a t2, so the value of t2 is changing. Okay, so the value of t2 will be minimum of 1 or qk by pk. So after finding this value of t1 or t2, you will put this value into a parametric equation of line and find the value of x and y. X and y means the intersect point, this point. The value of x, y means this point you are finding. At this point your t is 0, at this point t is equals to 1, and this point it is intersect point. You are finding the value of x and y. Is it clear? Again, one more case. If your line is passing like this, your line is passing like this, is consider, means here it is two intersect point. This is your point x1 y1 is initial point, and this is the end point x2 y2, and these are the t1 value and this is the t2 value. T2 at this point is 0 and t at this point is 1. So the value of t1 and t2 we have to find using this two equation, t1 max or t1 min. Okay, is it clear? One more thing, if your t1 value, the t1 value should always be less than this t2, means we have reached this point earlier than this point, so always the value of t1 should be less than t2. If it is this rule is violent, means your values t2 is less than t1, then this it is showing you are completely outside from your clip window. When this line is intersecting two boundaries, then 2 points t1 and t2, always t1 should be less than t2, because t1 you are reaching this point earlier than this, so the value of this t is should be less than this. Is it clear to all of you? I think many of students will not understand what. Yeah. Is it clear? Am I audible? Okay. 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 So if it is not clear, don't worry. Let's take one example and it will clear what happening here. Let's take one example. Okay. Forward to share the screen. New page. Let's take one example. You just consider you have given a clip window x w min equals to 5, x w max equals to given 10, and in the same way y w min is just consider given 10, and y w max is just given 10 20. This is the your clip window. If you draw the clip window, you will see like this. Your x w is 5, just consider it, here it is 5, it is 5, and here it is 10. This is 5, this is 10. The same way your y min is 10 and y max is 20. This is the case, means your clip window is here. This is your clip window. Okay, there is your clip window is given, and just consider some points, one line x1 y1 equals to, just consider 3 and 25, and x2 y2 is just given 7 and it is 15. Okay, this is your line. Means the first point is 325, it is here, and 725, sorry, 15, it is around here. Okay. So this is your line. Okay, let's change the position, it will be more easy. Not 3, it is just consider 6. Just consider 6, be more easy. 6 to 25 to this line. This is your line. Okay, so this is your line. Just find the value of p1, p2, p3, p4, and q1, q2, q3, q4. The value of p1. If you remember, the equation of p1 is minus delta x, p2 is delta x, p3 sorry, p3 is minus delta y, and p4 is delta y. Okay, so delta x means x2 minus x1. Your x2 is 7, x1 is 6, so it is 1, and it is delta x, and delta y equals to y2 minus y1. Y2 is 15 and y1 is 25. Okay, so the value is minus 10. So put this value. Minus delta x means minus 1, this is plus 1, this is minus delta 1 is plus 10, and it is minus 10. You find the value of p, and same way find the value of q1, q2, q3, and q4. q1 is x1 minus xw min. q2 equals to xw max minus x1. q3 equals to y1 minus yw min, and yw max minus y1. Put this value in this equation. x1 is here 6 minus yw min is 5, and yw max, which is 10, minus x, which is 6, x1 sorry, y1 is 25, minus yw min, which is yw min is 10, and yw max, this is 20, minus y1 is 25. Okay, write this. This is 1, this is 4, this is 15, and this is minus 5. Okay, so we have find the value of p and q. Okay, and after finding the value of p and q, first if it is any value is 0, no, so this line is not parallel to any boundaries. For these values 2, p1 and p4, it is negative. P1 and p4 is negative, means it's showing at this point you are entering into region. For p1 means this line, as you can see, it is entering, and p4, it is top boundary is entering, as you can see, from for these boundaries entering into your clip window, and positive means it is exiting. For p2 and p3 means right boundary. If you extend this line, you can see for this right boundary it is exiting. Let me draw and show you. If this line, if you extend, this way. As you can see, for this right boundary it is exiting, and for this left boundary it is entering, and for the bottom boundary, as you again see, it is for this boundary it is exiting, and for the top boundary it is entering, for the left boundary it is entering. Okay, so this is the meaning of this value of p minus and plus. Okay, so pk is less than 0, for which case 1 and 1 and sorry, p less than for p1 and p4. Okay, so find this value for this t1. T1 is max of 0 qk upon pk, max of 0 qk. For we will calculate for the 1 and 4. For 1 q, let me write complete, q1 p1 and q4 p4. Put this value, max of 0 q1 and p1, q1 divided by p1, q1 is 1, p1 is minus 1, so 1 divided by minus 1, sorry 1, and q4 is minus 5 and divided by p4 is minus 10, minus 5 divided by minus 4. So max of 0 minus 1 and minus minus plus, so it is p4 is 10, 10 10 minus 5 divided by minus 10, it is minus sorry, minus cancel 1 by 2. So which value is greater or maximum is 1 by 2. So the t1 value is 1 by 2. Value of t1 is 1 by 2. The same way find the value of t2, which is minimum of 1 into qk pk. Okay, minimum of 1 q1 p1 q1 p4, min of 1 minus 1 1 by 2, which one value is minimum, minus 1. Okay, so t2 is minus 1. Okay, so find the intersect point on your equation, x equals to x1 plus t into delta x. x1 is 6 plus t is 1 by 2 delta x. Delta x is 1, I think. Delta x is 1 into 1. So the value is 6 plus half, 6.5. And same value, find the value for y intersect point, y1 plus t into delta y. y1 is 25 and delta y equals to minus 10. 25 t half and 25, sorry 10 is minus 10, I think it's minus 10. Let's check, let's see, it is minus 10, yes. So when you calculate 25 minus 5 is 20. So the first intersect point xy equals to 6.5 20. Okay, so you find this point, and this value t2, as you can see, is the value is minus 1, which is not into between 0 and 1, so we will ignore this value. Yes. Why we are ignoring this value? Because the left boundary, if you extend, then only we will find this intersection. So the intersect point we have find it is 6.5 20 until the end point. Okay, so we'll cut this line from here. Okay, if it is clear you can speak, or if it is not clear you can again you can also speak. Or if you want to check for the pk value is greater than 0. Pk value is greater than 0 in the two case. P2 and P3 are the case where pk value is greater than 0. Okay, it is positive number. So when you find the value of t in this, apply this equation, you will get a value from not in between 0 and 1, means this value is not considered, means it will be ignored. Is it clear? Let me see chat. Is it clear? No problem if it is not clear. No problem. Okay, let's me show one more example, and I'm sure it will clear you the whole concept about the Liang Barksky algorithm using one this PPT. It is will clear you. Am I audible? Am I audible to all of you? Because I'm not getting any response from your side. Am I audible?
Yes, you are audible.
Okay. So let's see one more example, and I'm sure it will clear you the whole concept about Liang Barksky. This is the example. We have given a clip window. This is your clip window where XW min, you can see X, use the red pen. XW min, it is showing it's a 0. Okay. Using the coordinates, you can easily determine the value of X at this point is 0, means is the left boundary. And XW max is, unmute yourself and write tell the values of xw min, xw max, and xw yw min, yw max. Unmute your mic and speak this equation of your clip window, boundary equation.
10, sir.
Yw max value is, Aishwarya, yw max is what? Okay, yes, somebody write in chat. Okay, yw min is also 0, as you can see this line, and yw max is 10. Okay, so these are the boundary of your clip window and the given point x1 y1 and x2 y2. x1 is zero point 0.5, x2 is 3, and y1 is 15 and y2 is 9. This is the given now equation. Now find the intersect point. Okay, so first we will find the value of t for the left boundary. We will find the value of t for this left boundary. This is your left boundary. This is your left boundary, and at which time, t is just showing this or symbol of the time, at which time this line will intersect your left boundary, we will find. Okay, so for finding this intersect point time, there's only one equation. Divide your q by p. Divide your value of q by p. Okay, and for all the four boundaries, remember one formula to find the intersect point time, at which time that boundary is intersect by this line, is q by p. And here I just tried the q by p, and the value of q, if you remember, for the q1 it is x1, it just consider it's a 1, x1 minus xw min, and p1 value is minus delta x. If we remember the value of p and q, this we have derived from the equation. So this value I have just put for all. at right boundary. This is the right boundary of your clip window, and at which time this line is intersect this boundary at this point, and we have just finding the time at which time it will intersect at this point. So again q by p, we are calculating what the right side means q2, so q2 divided by p2. Just put this equation for the bottom and bottom boundary of your clip window, at which time this line will pass from this bottom line at this point. Okay, as you can see, so we will find this time t. So again q3 by p3, and the value of q3 and p3 I just write in this equation. And for the top boundary, at which time it will cut your top boundary. If you extend this line, you will see at this point, at this time, it will cut this boundary. Okay, so again q4 by p4. I just put the value of this x0. As you can see here, x0 is just a symbol of x1. Okay, minus 5, xw means 0, qx, sorry, delta x, which is x2 minus x1, 3 minus 5 8, sorry, it's x2 minus x1, x2 is 15. Okay, sorry, I just write the wrong value, it's a 15. X2 is 15, x1 is minus 5, and y2 is 9, and y1 is 3. Okay, I've just typed the wrong value. Okay, so this 15 minus 5, this is 20, and you will minus 5 divided by minus 20, you will get 1 by 4. So at the time 1 by 4, it will cut your left boundary or intersect this left boundary. At the time 1 by 4, this line will intersect your left boundary. Okay, for the right boundary, this is the right boundary. Again you put the value and find that at a 3 by 4, at the time 3 by 4, it will cut or it will pass from your right side boundary. In the same way for bottom, at which time it will cut the bottom boundary. This is the bottom boundary. Okay, so when you put this value, you will get minus 1 by 2. So minus 1 by 2, it will cut your bottom boundary. At the top boundary, it will cut at the 7 by 6. So now absorb the value of t. Always your t should be 0 to 1. Here as you can see, it's a positive number and its value is between 0 and 1. So we will consider this, means it will intersect your left boundary. 3 by 4, again it is between 0 and 1. So again we can say it will intersect your right boundary. The value of minus 1 by 2, as you can see, minus 1 by 2, the value is not between 0 and 1. So we'll ignore this value. It will intersect your bottom boundary, but it will outside of your clip window. We will ignore. It is intersecting your bottom boundary, but it will outside from your clip window. So we will not consider. We will just ignore this value. What the value is not between 0 and 1, we will ignore. As you can see here, the value of 7 by 6 is some positive 1 point something. It is greater than 1. So it will intersect your top boundary, but outside from your clip region. So we will just ignore. So what the value which is between 0 and 1, those values we will only consider. So here as you can see, left and right boundaries, it is intersecting on the valid values. So we'll find this only these two intersect point. It is intersecting at this point also, at this point also, but which is outside. So we will just ignore. The remaining value which is valid only we will consider. So these two left and right boundary it is intersecting, which is the value is valid. Okay, so these time 1 by 4, what is the value of x and y? Time 3 by 4, what is the value of x and y? These two value will find, and the this line between these two points we will consider the remaining line which is outside. We will cut or clip. So how we will find these point? Just simple, put the value in your parametric equation of line. If you remember, I'm just again writing parametric equation of line and put the value and find the value of x and y. Value of equation is x equals to x1 plus t into delta x. What is the value of x? Minus 5 plus t. This time we are finding the value of x. So what is the t value? Is 1 by 4. Delta x. What is the delta x? If you clear, it is 20 around. Okay. So 20 10, it's minus 5 plus 10 is 5. So value of x is 5. Value of y1 plus t into delta y1 is 3 plus t, 1 by 4 delta y is 15 plus y 6. So 3 plus 4 by 6 is 1.5, means 4.5. So this is the point 5.5 4 5 and y value is 4.5. This is the coordinate of this point xy at which this point is intersecting. The same value you will find this intersect point. Where the change the value of t, this the value of t is here is 3 by 4. Just put the value of 3 by 4 here and find the value. Okay. Now, is it clear? Now, is it clear? Am I audible? Okay. I think now is it clear to all of you what happening in this Liang Barksky? Okay. 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 Thank you. So let's see one more example, simple example. If it is clear, then more next example will be easily clear. This example. Here we have given our rectangular area or the clip window. Here clip window x the left boundary is 0, means the value of x is 0, and right boundary is 10, bottom boundary is 0, and right top boundary is 10. Okay, you can easily see this is your top boundary, this is bottom boundary, this is left boundary, this is right boundary, and our given line is this. Okay, given line is this -8 to 14. Okay, now we have to find the which area is inside or what the area which is outside. Again, we will calculate the value of t for the left boundary. This is our left boundary, and at this boundary, which time this line is intersecting. So again, q by p, value of q you calculate, value of p1 is you calculate, determine this value, you can find the value of 4 by 5. Okay, 4 by 5 value find for the left boundary. For the right boundary, this boundary, at which time this line will intersect right boundary. As you can see, it is not intersecting, but if you extend, it will intersect. So you will we are finding the value of 9 by 5. At this point, at this time, this line will intersect your right boundary. At the bottom, this is the bottom. As again, you can see it is not intersecting. If you extend, then only it will intersect. So you find the time at which time it will intersect your bottom boundary. The top boundary. This is your top boundary, and it easily you can see it is intersecting. Is 2 by 3. So these are the time at which this line will intersect to your boundaries of clip window. Now our condition. T value should be between 0 and 1. This is your initial point and this is your end point. Okay, so here the value of 4 by 5 is it is between this. For the left boundary, it is intersecting in the valid value. For the right boundary, the value is greater than 1. We will completely ignore this right boundary. We will completely ignore because the value of t is greater than 1. We will not consider this point. So we are ignoring this right boundary. The bottom boundary, the value is negative. Again, you can see there is no should be a negative value. Again, you will ignore this value. In the top boundary, the value of 2 by 3, again its value is between 0 and 1, so it is the valid value. Okay, so the top boundary, it is a valid value. But what is the problem? You can see this is the outside, but two values are valid. But if you remember, t values should always be less than t2. Here, as you can see, this value is greater than s. If you find the value of 4 by 5, it is around zero point 0.8. In the value of 2 by 3, it is around 0.66 something. As you can see, t2 value is less than t1. It's not, it's not valid. Okay, always t2 should be less than t2. So this 2 point again we will ignore, we will not consider. So all these boundaries not uh, inside your clip window. When the complete line is not inside your window, you completely ignore, because none of the condition is satisfied for the t value of t. Okay, so, so again, I'm just repeating. If you get the valid value, check the value of T1 and T2. T1 always should be less than T2. First, you enter the T1, then T2. Here it is happening reverse. Reverse means that T2 is greater than T1 is greater than T2. Okay, so ignore all this four condition and completely you reject this line. It is because it is completely outside from your clip window. Okay, so please write the attendance in chat box. Write T for tiger in attendance box. If you have any doubt, you can ask, because the time is over. In the next class, we will discuss the next line clipping algorithm, which is Nicole line clipping algorithm. We will discuss in the next class. So please, if it is possible, please read about it from internet or any book. Okay, so please write the attendance and leave the class so I can see how many students remain to write the attendance, because the time is over. Okay, thank you. I'm ending this meeting. Thank you.